The purpose of this session is to first of all introduce you to the concept of Python. Yeah, so you're able to ground yourself firmly into the tools that we'll be using in the course. So we had mentioned to you that we'll be grounding ourselves in the use of Python because of its particular that make it more versatile and more agile in the implementation of our data science work. Yeah, so let's begin. Yeah, so just to start off, I wanted to say that, and this is for those who are software engineering background like Sanjay. So there are two different parts of Python. So there's Python for web development, and there is Python for data science. So what we'll be focusing on in this course will be Python for data science. Later on at the end, towards the end of this, when you like to publish your code into web frameworks, now we'll be showing you how you can use Python for web integration, but that's at the very finality of doing the data science analytics work. Yeah, so let me start by saying that what's in front of you are notes. I'll upload them shortly into Slack. Yeah, so at least you can be able to also download them. Yeah, I just wanted to share with you some of the attributes of Python in terms of its history and its development, and also look at some of the components of Python that we'll be delving deeper into. Yeah, so when you look at this link here, you can read more about the foundation of Python, a high-level multipurpose programming language that is in a wide range of domains and technical fields. Yeah, so this is the Python summary. Yeah, so we're saying it's an interpreted, oriented, high-level programming language with dynamic semantics. Yeah, so they built in data structures combined with dynamic typing and dynamic binding, making it attractive for rapid application development, as well as for use as scripting or glue language to connect existing components together. Yeah, so Python simply is to learn syntax, emphasizes readability, and therefore reduces the cost of program maintenance. Yeah, so Python supports program modules and packages, which encourages program modularity and code reuse. Yeah, so we see that Python interpreter and the extensive standard library are available in source or binary form without charge or all form or other major platforms. Yeah, so then also we see that it can be freely distributed. Yeah, so let's look a little bit deeper into more granular the summary of it. So it's an object-oriented language. Yeah, by that we mean it can read both from the script and but also the script that you're writing and also from the hardware. Yeah, so it's also can be interpreted. Yeah, so that means that it's easy for you to understand it. Yeah, so very easy in terms of application. It borrows into the most commonly used semantics. Then the other part is it supports dynamic data types. Yeah, so whereas other languages are not dynamic in the terms of the data, we'll see the different types of data that are supported by Python and how that comes advantage in the data science work. Yeah, so we talk about floats, integers, all of data types, yeah, including strings that can be used when coding. So this also is a key component, especially when you're looking at finance analytics or marketing analytics or data analytics, because you find the dynamism of the data that you're using is different. You can transform data from one type to the other. Yeah. So the other aspect is about independence from platforms. Yeah. So it doesn't really depend on. It doesn't have any other dependencies. Yeah. So if you can code using Windows applications, you can code using Mac applications or Linux. Yeah. So it's simple to and easy grammar. It's got high level internal object data types, and then also automatic memory management. Yeah. So remember, I'd mentioned to you about the fact that it's got some computational power in it. Yeah, so Python itself is a tool that is used for computational ability. We can put some more advanced mathematical equations in there and they can be computed. Yeah, so let's look at the next slide. Yeah, but before we do that, is there anyone who would like to understand what open source means. We had touched on it. So I just want to hear from you in terms of you typing here. What are some of the softwares or programming languages you use at work if you interact with the IT guys? If you can just type here the type of programming tools that you encounter at your workplace. Yes, Vicky. Vicky says Java. Okay. Yeah. Well, yes, I don't have to. Any other contribution? JavaScript. Okay, so besides it, just feel free to type in anything. Cedric said, what are some of the programming languages that we encountered being used both at work or elsewhere? Okay, you know Java, all right? Yeah. So, so I'll be liking to make a reference based on what you know. Sanjay, I've not heard from you. What are some of the programming languages that you use frequently? Ms. Kennedy? Okay. All right. So Oracle, yeah, it's a business intelligence tool. Yeah, so it's not necessarily a programming tool, but it's got some interfaces where you can write code on. Yeah, yeah. So thanks for asking that. So at least we can create for you some clarification around. Yeah, so Oracle gives you interfaces where you can write your code, and when you write that code, you can integrate it with what you're working on. Yeah. So that makes that distinction is important, so at least to make it clear where you're coming from. Yeah. So I'd like just to mention the aspect of where it's free and open source. So how does this affect, for example, how yeah, you interact with this Python? One of the issues we faced with organizations is they refuse uh, they refuse the employees to use open source tools because of they feel that the data there is unsecure. Yeah, but we would like to encourage you that, of course, being open source does not necessarily mean that your data is exposed to anyone. Yeah. So there's something I'd like to explain at this juncture, which means when we downloaded that application on your machines, it means that the machine is sitting right there with you. Okay. So it's not that it's on cloud. It's on your machine. The software is there. No one can have access to the data that you are processing in it. So it's sitting in your hardware. Yeah, so when you interact with the IT departments, and if you're using an office machine, yeah, try to encourage them. It's just the same way like you have Excel, and uh, Excel is even more what do you call it? Excel, it's even more sensitive. It belongs to Microsoft, so Microsoft can be having that data. Yeah, but Python is very open source. Yeah, so that data cannot be anywhere. It's only with you who's handling that machine. Yeah, so feel free to use Python without fear. The tools that will be showing you will require that you uh, upload a lot of data, yeah, from your different sources. So I don't want you to have that fear that your data is being exposed. Okay. Yeah. So yeah, just the key aspect I wanted to mention there under resource. So some little bit of history around this. So let's see, for example, uh, I mean, I don't know whether you've heard about the history of Python. So the name was picked in December 1989, and the guy who founded it was called Guido van Rossum. He now works at Google. Yeah. So Python, for example, .org website was launched in 1996, thereabouts. Yeah. So we had the first version, which was 2.0. We had the Python Software Foundation in 2001, 2.4 released in 2004, 2.5 released in 2006, current version actually 3.6. Yeah, yeah, you saw us downloading it over the weekend. The current version is 3.6. Sorry, Mula, we don't have any ladies in cohort 3. Yeah, I see you're asking where the ladies went. But yeah, this cohort unfortunately does not have any ladies. Yeah, but Karibu, yeah, feel free to join us in this cohort as we take our journey into Python. Yeah, so the next part, yeah, we've mentioned about this. Yeah, so Python, the majority of supporting libraries and tools available are open source and generally come with free and flexible licenses. So any technology comes with a license for you to use that technology. Yeah, so what we're talking about here is an aspect of you using, for example, a license that has been given by another user, for example. Yeah, so you guys develop technology based on different frameworks. Yeah, so those technologies help you to build up on something, on some solutions. So what you're talking about licensing is that Python does not require you to pay any license. And this is where the difference with Python and R come in, because some of you have been working with Python and they always ask, oh, what's the difference between Python and R? So the big difference between Python and R is Python is fully open source, so you're not required to pay for any license. Yeah. Whereas when you work with the R, it reaches a level where you have to pay for some licenses. Yeah. Yeah. You pay for some licenses, and actually some of the things that you will encounter when you're using R gets a little bit complex. Like for example, yeah, so it's important that you actually have a look at how you're able to approach the issue of licensing under Python. It's purely free. The other characteristics is interpretation. So the reference C Python implementation is an interpreter for the language that translates Python code at the right time. The effect is that it's multi-paradigm. Yeah, so it means Python supports different programming and implementation paradigms such as object orientation, imperative, functional, or procedural programming. Yeah. So the other part is about multi-purpose. Of course, I didn't mention about being open as a data science tool. It's also used for low-level system operations. So, for example, a device, the devices which have been programmed using Python that can communicate, yeah, with hardware. Yeah. So yeah, for example, C++, yeah, the programming language communicates with hardware. So that can be written on top of Python. So this multipurpose bit is what I'd like you to start embracing. So you might find different guys using Python, yeah. So don't worry about you are using data science. Someone else might come that is good in Python, but another part of Python that he does is quite different. For example, there's something called Python for GIS. Yeah, there's another thing called derivative finance using Python. Yeah, so the multi-purpose use of it. Yeah. So Keter, actually, you're asking a question here. Spelling of the language you have compared with Python R. Yes, it's the first one. It's called R. This one. Yeah, just that's the line. Yeah, so R, it was acquired by Microsoft. Yeah, it was acquired by Microsoft. It's used mostly by statistics institutions. So very nice library is already custom made for you, so you don't have to build code from scratch. Just go plug and use a code. Yeah. Okay, so let's go to the next one. Yeah, so feel free to ask me any question at any point if you want to get clarification. Yeah. Okay, so we talk about language properties. So everything is an object. We have modules, classes, and functions. And then we have exceptional handling of that language. Yeah, dynamic typing and polymorphism. Yeah, so that means the language changes and fits any structure that you give the command. Then we have static scooping. So we'll be functionalities in some of these functionalities in action. Yeah, so this is a theoretical part, but we'll be switching into the scripting, and I will be seeing some of these actions being done in real time. Yeah. So we also have operator overloading, then indentation for block structure. Yeah, so you'll be seeing how you write the code and how the code side to the other. So we'll be describing each of these properties when we go to the notebook. Yeah. So Python is available in the most important operating systems such as Windows, Linux, and Mac. We downloaded Python for Windows. We also had Python, yeah, for Mac. So whenever you went to that platform, you're able to log in and you're able to click on the Python for Mac, and you saw it was not able to run. So some of you had to go and download the right one for Windows. Yeah, so we mean it communicates with the operating system. So this cross-platform feature enables it used both to build desktop as web applications. Yeah, it can be used on the large clusters and most powerful servers, as well as small devices like the Raspberry Pi. Yeah, so how many of you have heard about the Raspberry Pi? It's a small device with very low latency computational power. It's so cheap; it costs something like 500 shillings, but it's the most cheapest computer actually. It's 500 shillings, but it can be used to build technologies like CCTV cameras, low latent detection devices, IoT. Yeah, I saw someone even building a Netflix receiver out of a Raspberry. Yeah, so uh, some Python code is written and fits into Raspberry. Another part is dynamically typing. So this means types in Python are generally inferred during runtime and not statistically declared as most compiled languages. We have integration aware. So in contrast to the majority of other programming languages, Python uses integration for marking code blocks instead of parentheses, brackets, or semicolons. Yeah, so you'll see how this works. We'll be pushing code across the notebook. Then there's also something called garbage collecting. So it has an automated garbage collection, avoiding the need to programmer to manage memory. Yeah, yeah. So Python itself has got an embedded memory feature which enables it to compute and store uh, data and instructions. Yeah, so you do not need to remember some code you wrote previously. You just need to call that function and then it executes. Yeah. So when it comes to Python and Python syntax, so we have what we call the Zen of Python. Yeah, so the Zen of Python is like they believe, what we call the philosophy of Python. Yeah, so this is just like a something written by, you can be reading it. Yeah, it's like a poem which he wrote to, uh, you know, in praise of Python. Yeah, so something, you find some people printed these and hang it on their wall somewhere in their offices. But it's good that you read about it. It's very fun, and it also gives you some, you know, good background about that. So we are doing now. We are now in 2019. So there's one which was released last year in December, the 3.6. So if you look at this trajectory, it's like every 2 years there's a new version that's released. Yeah. Yeah, so what are these versions? Versions mean if you go to an older version, yeah, the speed of your computer is faster than that version. So it does not support some libraries. So you need to be careful when we'll be doing the coding. We'll be telling you some libraries were available in earlier versions, but they're now obsolete. So if you run it in an earlier version, there's some instructions you need to give your machine for that version to be identified. Yeah. So yeah, so we'll be shortly moving into the Python environment. So these libraries and tools are generally imported when they're needed. Yeah. So for example, you might import something called Numpy. You might import something called Pandas. So some basic mathematical calculations are always carried out. Yeah. To uh, without any importing. Yeah. While more complex mathematical functions need to be imported through the math library. Yeah, we'll see which libraries these are and how we'll be using them. So the libraries which are for data cleaning, the libraries which are for visualization, the library which are for scientific computation, the libraries which are for finance analysis. So all these libraries will be there. We'll be looking at them step by step. So whenever you hear a word being mentioned like a library, just know it's a tool that's going to use to compute. Yeah. All right. So a lot of this is a continuation of what I've mentioned in summary. Yeah. So this I'll make these notes available to you. You can read till the end because there's just a few more slides remaining here. What I wanted to do at this point was to give you time to open the notebook. Yeah. So I'll be opening another presentation, but before that, I want to close this one. I want to go and let me just check one more here. Yes, so in the meantime, I want you to open the notebook. Yeah, that we went through. So once you open it, we'll be going into it. So just give you some time to open. Okay, so Derek, yeah, once you open, just confirm there that it's done. Okay, good. So Mul, I think you're on mobile phone. Been waiting for you, but I think you'll not be able to open because you're using a mobile phone. Yeah, Keter, have you been able to open? Ricky, have you been able to open? Oh, okay, good. Yeah, so very quickly, just to run it through. Yeah, that's we'll be looking at a overview of Python libraries for data scientists. Yeah, and then how do you read data, selecting and filtering data manipulation, sorting, grouping, and rearranging. So on the 27th, when we have our next session, we'll be focusing on this part. Yeah, and this part. And then we'll be looking at descriptive statistics and then inferential statistics. So these are the kind of components that we'll be delving into when we go into the data Python for data sciences. Okay. Yeah. So I'll be showing you shortly the script, but this is the main popular Python toolboxes and libraries. So perhaps what we call Numpy is what you call numerical Python. So it's used for analyzing numbers. We have SciPy, which is scientific Python, which is used for it's the one which carries all the Python, all the mathematical equations that you want to use, whether you're doing regression analysis, random forest classifier. So this is the science part of Python, and we'll be using a lot of this. And then we have Pandas. So Pandas is the library that we use for data cleaning. Okay. And then we have Scikit learning. Yeah. So this also has got machine learning. So when you reach the machine learning part, we'll be using more of the Scikit learn. Then also we got visualization libraries, Matplot and Seaborn, very mostly commonly used. So during our second month, we'll be going into these libraries and seeing how they work and how you're able to create visualization using them. Okay. So let me just introduce these libraries so that when we go to the notebook, we go seamlessly. Yeah. So NumPy introduces objects for multidimensional arrays and matrices, so as well as function that allows to easily perform advanced mathematical and statistical operations on those objects. So it provides vectorization and mathematical operations on arrays and matrices, which significantly improves performance. Yeah. So in short, what this means is a NumPy, a numerical Python, helps you arrange the numbers in preparation for analysis. Yeah. So it's a good way for you to classify dimensions, a good way for you to identify missing numbers, so that by the time you're starting your analysis, you are very clear on where you want to, which part of your data that you like to work on. Yeah, so I'm glad that we'll be starting off with this, so at least you can have and appreciate how you can use it for the basic work, especially in finance, when you have missing records or you want to analyze and prepare data for analysis. So we use it for preparation purposes. And when you come to the next part, scientific Python, so collection of algorithms for linear algebra, differential equations, numerical integration, optimization, statistics, and more. Okay, so this is by the third week of by the third after next week, we'll be going into SciPy when we look at some basic linear algebra, statistics, and how you can use this mean, standard deviation, mode, how you can use this to create some mathematical computation. Yeah. So it's built on top of a numerical Python, but it's also part of the science Python, which this is the link. Yeah. So once you get these slides, you can click there to read more about it just for your own knowledge. Yeah. So these are very key libraries, and you'll be seeing them a lot. Every time we start coding, you see we'll giving instructions, import Python, and then you go to import NumPy, import Pandas, import SciPy. So import means you're calling that library so that you'll be using it later in your code. Then Pandas. So Pandas adds data structures and tools designed to work with table-like. So it's similar to series and data frames in R. Okay, so R has got a different language. They call it data frames, but here we call it pandas. Yeah, so it's a fun way of playing around with numbers. So you can see it can provide tools for data manipulation, reshaping, merging, sorting, slicing, aggregation, and then allows for handling of missing data. So when you look at these pandas at work, it gives you an impression that the data that you want to analyze is critical and it's good for you to be able to appreciate, how you can create different dimensions and how you can actually can help you reveal patterns of missing data. Yeah, so this is a first part for data science, and unfortunately, it's the one that takes most 80% of the work goes into data cleaning. We use these tools more and more to be able to create more cleaner data that can give us better insights once we deploy the model for analysis. We have a scikit-learn. So this provides machine learning algorithms, classifications, regression, clustering, model validation. So unfortunately, data science has a lot of focus on this. Because every time you talk about machine learning, people start listening to you. But we often get that before you reach there, you have to do this. You have to clean the data. You have to plan and arrange your data in a certain format before you apply sense the numerical cipher kits. Yeah. So these kits are good. So that's where you do your linear regression, your clustering, model validation. Very fantastic ways of these tools that these libraries are. I'd like to encourage you to see how you can build up on them. Yeah, as we reach that stage, this will be in the third month when we'll be looking at this. Yeah? So then we have matplot. So matplot is also another library. Python, it's a two-dimensional plotting library which produces publications, quality figures in variety of hard copy formats. Okay. Yeah, so I'll shortly be opening some notebooks here just to show you some of the visualizations that are being done with this once I close my presentation. Yeah, but it's a set of functionality similar to those in MATLAB. So those of you with a mathematical background, you use this MATLAB to do analysis, or if you've done your masters, you're using SPSS, to do your data collection and analysis. So this is a similar platform to MATLAB and then we have Python libraries, for data science. Yeah, so for example, this is Seaborn. Seaborn is also another visualization. Yeah, similar in style, popular to ggplot. Yeah, so this helps you to create nice visualization, and we'll be seeing a matplot example to be able to create very nice creative visualizations, out of it that you're given. Okay, yeah, so this is another side. So for example, what you're doing, those of you doing um, data engineering will be going to a phase where we log you into the cloud, which has the complete environment. Yeah, so once you reach that stage, you'll migrate all your work, all the Python. Yeah. For the rest of the cohorts who will be doing the data science will still compute from our machines. So this is where it all starts. Yeah. So I'm happy we are here, and I'm happy that we've all been able to open the Jupyter notebook. Just now, I mentioned about these libraries. So this is how they appear when you say import Numpy as NP, import SciPy as SP, Pandas as NP. So you'll be seeing this a lot more frequent. Yeah, this is always the first line of computing. Yeah. So I'll not be continuing with these slides. I want to close my presentation. And for the remaining part of this presentation, through the Python notebook. So I will start sharing my screen. Okay, so we can walk together into the notebook. Just give it time, it's opening. Okay. you able to see my screen now? So I will not be able to see the chat. What I just want to confirm is just type here that you're able to see my screen sharing. Okay, Ricky said yes. Okay, good. So let me start now on this. So yeah, so we are here. We came here. Last time I showed you how to load and open your Python notebook. Yeah, so you came, you click there, and then you open it. Okay. Now this notebook is the introductory notebook that you have. So put some notes in it. These notes will help you to read and actually be able to appreciate some of the tools that Python has. So I just want to teach you some tricks around this notebook. Yeah. So if you see, so this is where I want us to work along. So when I show you something on the screen, I'll be giving you some time. Go and do it on your machine, and then you come and type that, yeah, you've executed those instructions. So I'll show you the first of all the basics. Now we have this file. Last week we looked at how to rename a file. So we all successfully came there, and then you could type in your name here. So I type in my name, Tim. Then could say that today's date is April 18. Okay. Then I click there, rename. Okay. So when you say rename, it appears there, just been renamed. So this is what I want you to do. So because today is April 18th and I want us to do this as an assignment, so I want you to just go type in there as we move along. Then after that, we'll come here. But there's something we call save and checkpoint, because you're offline, this script is not refreshing itself, so it's not saving by itself. You have to save it physically when you're working offline. So I want you to take note what's happening here. When I click and I say save and checkpoint, you'll see what's happening where I'm putting my cursor. It shows what time it's saved. Okay, that's another key function. The other ones are download. I showed you how to download it and upload on Slack. So thanks for those who managed to upload. If you have challenges still, this is how we do it. So you come there, you select notebook. Okay. So once you select notebook, it will come there under downloads. And you go to downloads where it's gone to, and you can be able to pull it. You can see, you can pull it and put it on your desktop. Okay. So that means you're able to open it from anywhere. But you can only open it using on Python. Yeah. So one of the key functions I want you to take note for that. If you want to open a new notebook again, you could just come here and write new notebook. Okay. Now the other part is about editing. So you can just the same way you do with Word. Yeah, you can move, you can merge cells above, merge cells, you can cut cells. Yeah, so we don't use this quite often, but just that's what it does. View also the same. You can choose what to view. So toggle header, toggle toolbar, toggle. We'll explain this a little bit later. Insert. So this is what we're using more frequently. So for example, I want you to observe what's going to happen here. This is line 1. So when I say insert cell below, you'll see a new cell has been inserted. So if you're writing a line of code and you want to insert a new line to write code, that's where you come. Insert cell below. Okay. Yeah. Then this cell, you can run cells. So for example, how do you run a cell? So what is running a cell? So running a cell is executing the command that's inside. So at this point, I want us to do an exercise. So I want us to come here. First of all, start with print hello world. Click there, and then come and click on insert cell below. Or cell, I mean cell. I've done cell above. So yeah, we'll do yeah. So could do you see insert cell below, so which is here. So I want you to print exactly, type what is there. I want you to type print in brackets hello world, just like this. Print and put your bracket, then put the asterisk hello world. I want you to do that, and once you do, just come and so once you do, just come and type here done. Type on the dashboard, but I'll take you now. Type print hello world, then move on to the next. So this is what we call run cell. So when you come there, you run a cell, you do that. So you'll see it's printing the one there. Okay. So just come back to the once you okay, Ricky, I've seen yours. Okay, Sanjay. Yeah, so we all good. No one is gotten stuck. Okay. So I want to move to the next step. So this is a cell. You'll be using this line quite frequently. It's called the run. You'll be running. So when you run, it will come and print, publish, or rather, give the output on the next cell. So whatever is inside these lines is this is the cell. Now whatever is outside, this is the printed one. So this is a not. So let's move down. So there's some words which are reserved to be used in Python. So you'll see some words are coming out in okay. Some and now this green one are recognized by Python. For example, these blue words here recognize type it's certain format. Yeah, so if you play around with these words, when you're typing them, you're seeing them coming out in color green. Hope you're noticing that. Yeah, continue typing them. You will see. Yeah. Yeah, so that's how it works. So some of these words are coming out in different tones. Now there's some is like class, functions, variables. Yeah. So in Python it helps differentiating one entity from another. So what are the rules for choosing an appropriate identifier? Pairs can be a combination of the letters, e.g. lowercase a to z, or uppercase a to z, or digits 0 to 4. Yeah, so name like my class variance _1 and print this to screen our valid example. So an identifier can start with a digit, one variable is valid, but one variable is perfectly fine. Then also we see that keywords cannot be, yeah, so we cannot use special symbols like this, yeah, in our identifier. All right, yeah. So we have a Python statement. Now, what is a Python statement? So instructions that apply Python are called statements. So for example, 1 is equals to 1, A is equals to 1 is an assigned statement. Yeah. So in mathematics, we call this equals. But in a Python, we are assigning, yeah, A to the value A. Statement for other kinds of statement. Now, I want to explain something. When you see making it not readable, yeah, it means it's not so if you try to run this cell and print, it will not execute anything. Yeah, you see what it becomes now executable. Okay, so it says hello world. Yeah. So those are some of the tricks that we use in Python. We'll be continuing to learn just to the next one. Let's try to execute the same way we've done. So for example, if let me create a new cell here, insert cell below, and then I'll just copy this statement in there. Oh, Cedric, you're saying you didn't get the tricks? Yeah, so trying to explain the hashtag sign. This hashtag sign makes a statement become null. So if you can be able to catch it as I do it here again. So for example, this, you remove that when you put hashtag, it becomes a statement that doesn't mean anything to the code. Yeah, so let's execute it. So remember how to execute? So we used to come and say, so you see what has happened here. So it says there's an error in this code. Yeah. Why? Because the multiple statements on the same line, after each statement, you have to put a semicolon. Yeah. So it means there's a semicolon somewhere, which is, yeah. So we need to go and investigate where that semicolon is, where it's missing. Yeah, so this, okay. Car is equals to Toyota. So you come, let's put this here, let's put this here. So we nullify those two. So when you print this cell, yeah. So you could come here and say print car. See what happens. So you see it's printing the car. When you change, when you remove those semicolon, so you print Toyota. Print. Yeah, you can see the printing coming out here. Okay. Yeah. So when you come here, you say print car is equals to Toyota. So you see this is printing. Yeah, that cell is printing. So I hope I've been able to demonstrate that hashtag and what it does. Okay. Yeah. So I wanted to explain another attribute, and from here on, the most of the things we'll be doing will be more face to face. So any questions so far? Okay. Yeah. So I just want to conclude by showing you something else. So Python indentation. So indentation, just the same way you ident when writing paragraphs, ident when you're writing code. Yeah. Yeah. For instance, when you say for 1 in range 1 to 11, print I. Therefore, I in range 1 to 11, print I. So if I is the same as break. Yeah. So when I reaches 5, you break. So which means you stop. Yeah. So I want you just to copy these instructions, execute them. Of course, in your notebook, it's not executed. So do you know how to run a cell now? When you come there, you just click on run. Sorry. So when you come there, do the same thing. Write run. Okay. Yeah. So for example, here you can do 9. So when I reaches break 9, so it will print from I to 9. So I is used, it shows a real number. Okay. So that's what it does. So I want you just to, the exercise that I want to give you is to read and execute each of the cells, yeah, in this notebook. Yeah, so read the notes and then execute and see what will come out of it. Okay, yeah. So I want you to do that as an exercise and then email me, or rather upload on Slack under cohort 3. You just upload. So what we'll do when we meet on a face-to-face, yeah, we'll go through this one more time, and then we'll jump into Pandas. Yeah, so the session that we'll have on the 27th will be very Python oriented. We'll be doing Python using Pandas and Numpy. Yeah, so this is a short introduction just to get to introduce you to these notebooks. Yeah, so don't worry much about the syntax here. It's mostly for practice purposes, but we'll be showing you now more granular work on how you can bring in your data into play. Okay. Yeah. So any question? Oh, so Keter, you're saying you don't see those notes in your Jupyter. Did you open the file? This one? We uploaded it on Slack. If I just open Slack, with Slack here, cohort 3. Yeah, so you'll find it here. This one. Download this file and then open it on Jupyter. It's the same one, huh? Nope, that's okay. Yeah, Keter. But in case of anything, just contact me. I'll be able to understand. Yeah, so you'll find it there. Okay. Guys, yeah, so I'd like to wish you a happy Easter. Yeah, so have a restful long weekend with your family. We'll see you on the 28th, on the 27th, sorry. But we have the 3 webinars next week as usual. Yeah, so let's prepare for them. But in the meantime, have fun and take care. If you're traveling, have a safe trip to traveling.